Hello guys, it's Math with John. Today I have problem 7 to 9 in, let's see what worksheets I had. Yeah, section 4.6. We're going to be dealing with limits, so let's do this. Actually, no, then I go here, note. Okay, so let's do this. So let's see what I had for problem 1. So for problem 1, we have the limit. Let's make it purple. The limit is approaching, or x is approaching infinity, then we have x, x over, then x minus 2 over x. And so this is what's interesting about this problem, that we can see as x approaches infinity, we can see that even both, like the numerator and the denominator are both going to be approaching, because that's what it says here. X is approaching infinity, so it implies that x is going to be approaching infinity, and the denominator. So what does that mean? That if it's approaching infinity, wouldn't that just mean that it's going to be the limit of x approaching infinity, but then it's like x squared, and it's going to be x squared minus 2, because we're approaching infinity or both. And after that, now I'm just simplifying it. So if we simplify it, we take the x squared. Okay, then it's going to be the limit of x is approaching infinity. It's going to be, because x squared, it's going to be 1 over 1 minus 2 over x squared. Okay. Now, we can see that as x approaches infinity, you see how we have this x 2 over x squared. Well, we can just say that it's just because we can see that if we simplify it, 1 minus, it's just approaching 0. So it's going to be 1 over 1 minus 0. And so then, therefore, a equals 1. So that's our limit. So the limit is 1. Okay. Now let's do problem 2. Problem 2, we have, let's do like a pretty good color. So we have the limit of x is approaching infinity, then we have root x minus 6 over x, and divided by 3 over x plus root x. Yeah, I'm just putting parentheses. Usually with bigger problems, I like to do that. So now we can just look at the, what is it saying? So we can see that the limit is approaching infinity. It's going to apply both. But the thing is, we see that it's approaching 0. That means that the denominator is approaching infinity. So what we can do for this problem, we can use the L'Hopital rule. So what is the L'Hopital rule? So if you guys need a reminder, it's going to be d over d of x. This is why we use the parentheses, so I can see it better. And we just take the derivative of both. So just writing. Okay, then perfect. Okay, and then now we're just going to take the derivatives, applying L'Hopital's rule. So we get limit of x approaching infinity. Then it's going to be, so for this part, it's going to be 1 over 2 x plus 6. We take the derivative of that. X squared over. And then for the bottom, it's going to be 3. We get negative. And then denominator, that one, x squared, is going to be 1 over 2 root x. Okay, nice. Okay. Now we can just look at what we have. We can write as the limit, but it applies for both. So technically what I should write is limit of x is approaching infinity, and then both of them. But it's implying both right here. And just see. So this can simplify to 1 over 2. And so we can see that since it's going to be 0, and then it's going to be over, yeah, and then both of those 0. There you go. And we still have the plus there, so, and then, so now if we just simplify that, we get 1 over 2 over 0, and then if we use the indeterminate, so this is the indeterminate term, applying the L'Hopital's rule, so we could do d over x over 1 over 2. Or, I mean, my bad, it's kind of tired. X 1/2 over d over d of x, and then there you go, times 0. And if we take that, then we get e equals 0. So the limit of x approaching infinity is going to equal, or it's not equals, it's going to be 0 over 0, and then so e equals 0. There you go. Okay, now let's do problem 3. Okay, I'm going to go back to purple like that. So we have the limit of x approaching infinity and 4 to the power of x minus x squared. So we can see that the x is approaching infinity, but then we have the x minus x squared, which is actually going to be approaching negative infinity, because you see how we have the x squared, which is actually going to be going much faster and quicker than x. So what does that mean? So let's do it. So what we could do is we can actually write it as, give it, because this is kind of a problem inside a problem, I'm just going to think of it more like u equals x minus x squared. And now, instead of writing that, which kind of looks messy, I'll write equals 4 to the power of u. So if 4 to the power of u is going to be approaching 0, then this implies that it's going to equal 0. So that's math with Jon. Hope you guys enjoyed this.